Okay, this is the topology diagram here. R1 router, R2 router, and R3 router. R1 router we configure with a 10.0.0.10 and 20.0.0.10 here. R2 router has been configured with 20.0.0.20 and 30.0.0.10 here. R3 router has been configured with 30.0.20 and 40.0.10. So if you configure the IP address for the router here, router takes the IP address, convert into network address and store it in the routing table. So R1 router have 10 network and 20 network. Similarly for R2 router, we configure with 20.0.20 and 30.0.10. So R2 router has 20 network and 30 network. R3 router, okay, if we configure the IP address, R3 router will have 30.0.0.0 and 40.0.0.0. That means router take this IP address, convert into network address and store it in the routing table. Okay, that is the purpose, that is the router activity. Okay, so if you want to communicate from R1 router to 10 network and 20 network, yes, you can able to communicate. From R1 router to 30 network, cannot able to communicate because it's not available there in the routing table. The routes are not available there in the routing table. Suppose for example, if you want to reach my 40 network from R1 router, I cannot able to reach. Here in R1 router, if on R1 router, if you try to ping, if I check the connectivity here, if I try to ping 10.0.0.10, I can able to communicate. Similarly, if I try to ping 20.0.0.10, I can able to communicate. If I try to ping 30.0.0.10, I cannot able to communicate because the routes are not available there in the routing table. Similarly, I cannot reach my 40 network also because the routes are not available there in the routing table. The routing table, here I am having 10 network and 20 network. So it can reach, it can reach 10 network and 20 network only. It cannot able to reach my 30 network, 40 network because it's not available there in the routing table. So if you want to reach my 10 network and 40 network, what is required for us? We need a routing protocol. Routing protocol. So we have multiple routing protocol available. Today we are going to discuss about static routing protocol. Static routing protocol. So what is static routing protocol? Okay, static routing protocol is nothing but administrator manually configure the routes. Administrators manually configure the routes. This is called a static routing protocol. You can see here, administrator manually configure the routes to reach the remote network. This is called a static routing protocol. The routing table is created, maintained and updated by the network administrator manually. So that means administrator has to do all the activity. He has to create the table, he has to maintain the table, he has to update the table. If any routes are not available, he has to create a table. He has to create the routes, routes for the particular network. So everything has to be done by the network administrator. So if you want to do static routing protocol, we need to configure the static routing protocol in all the routers to get the full connectivity. If you want to get the full connectivity, we need to configure the static routing protocol in all the routers. Suppose for example, if I have 3 routers available, I have to configure the static routing protocol in all the 3 routers to get the full connectivity. Today we are going to discuss how we are going to configure the static routing protocol. What is the syntax for static routing protocol? That's what we are going to discuss. We understood that static routing protocol is nothing but administrator manually configure the routes. He has to configure manually to reach the remote network. The administrator has to create the table. He has to update the table. He has to maintain the table. We need to configure the static routing protocol in all the routers to get the full connectivity. So what is the syntax for static routing protocol? IP route, destination network, subnet mask, next hop address. IP route, destination network, subnet mask and next hop address. Okay, another method also available. IP route, destination network, subnet mask, exit interface. 2 methods in which we can configure the static routing protocol. Okay, here this is syntax. IP route, destination network, subnet mask and next hop address. Next hop address is nothing but IP address of the next router. IP address next router that will receive the packet and forward them to the destination network. Okay, IP address of the network next router that receive the packet and forward them to the destination network. So in this case, If you want to configure the static routing protocol, okay, in our own router, I'm having 10 network and 20 network. So I need to configure the static routing protocol for, okay, 30 network and 40 network, because 30 is 40 is not available, right? So I am going to configure the static routing protocol for our own router. How to configure? Here, 30 network and 40 network is not available. Okay, 30 network and 40 network is not available in my routing table. 30 and 40 is not available here in my routing table. 30.0.0 is not available. 40.0 also not available. So I need to write a route for 30 network and 40 network. What is syntax for configuring the static routing protocol here? I have to enter into R1 router. Okay. So enter into R1 router. Here I am going to configure static routing protocol, right? What is syntax here? IP route. IP route destination network. Which is your destination network here? 30 and 40 you need to reach, right? Okay, because 10 and 20 are already known by our own router. 30 and 40 is not aware of it, right? So we need to write the route for 30 network. So 30.0.0.0 destination network. Subnet mask 255.0.0.0. That is subnet mask. Next hop address. Next hop address means what? Next hop. Okay. Next jump. Hop means jump here. Okay. Hop means in English we can say jump. Next hop address. Next jump. IP address. So that means what? The IP address which is available in the next router interface. That is meaning here. You can see the definition here. Next hop address nothing but the IP address of the next router that will receive the packet. IP address of the next router that receive the packet. So when it comes to next address here, for our own router, I need to reach my 30 network, right? I have to go via this way to reach my 30 network. I have to go via this way to reach my 30 network. So my next jump from our own router, okay, next jump, this is my router, right? Next jump, next jump IP address or next hop IP address. IP address available in the, okay, interface of the next router. What is the IP address available here? 20.0020 is the next hop address. So 20.0020 the next hop address here. Similarly, if you want to configure, okay, my 40 network, I need to reach my 40 network, I need to write the route for 40 network also, right? And to write the route for 40 network also. Because our own router knows only 10 and 20. So we need to write all the network here. 30 network, we already wrote the route here. Then 40 network, we have to write. Okay. So how to write here? Same thing. Where the 40 network available? So from here, this is the way to reach your 40 network. Okay. So what is next hop address? So if you want to see the next hop address here, for our own router only I need to check. From our own router only I need to check. What is my next hop address? Okay, it should not be somebody say 30.020. No, from my R own router, what is my next hop address? Okay, I'm not saying next hop address here. I'm not saying next hop address. I'm saying here next hop address only. Next jump address. So whatever IP is available in the next router interface, that is your next hop address, not 30.020. So what is the IP address available next hop here? Next jump here, same thing. 20.020 is a next hop address. So here for this network also, for our own router, IP route 30.0.0 255.0.0.0 20.0.0.20. This is your next hop address. 20.0.0.20 is your next hop address. Same thing. Okay. So from our own router, if you want to reach with 30 network or 40 network, this is my next hop address. Okay, 20.0.20 is my next hop address. So for our own router knows about 10 network and 20 network. Okay, so from our own router, okay, if you want to reach my 30 network, okay, I am not having routes to reach my 30 network. So I am going for static routing protocol. So this is syntax for static routing protocol. What is the command? IP route destination network, subnet mask and next hop address. So IP route, okay, what is the destination here? 30.0.0.0. 30.0.0 is the destination network. Subnet mask 255.0.0.0. Okay, next address. What is next address here? Hop means what? Jump. Next term means next jump IP address. From R1 router, next jump IP address. Okay, or we can say IP address of the next IP address of the next router that receive the packet here. So that is nothing but what? 20.0.0.20 is your next address. So from R1 router, I can write 30.0.0 IP route, 30.0.0, 255.0.0.0, 20.0.20. Here it should be 40, right? 40. Okay, if you want to reach my 40 network also, we have to write the route 40.0.0.0. Okay, 255.0.0.0, 20.0.0.20. If you want to reach my 40 network, whether it's a 30 network or 40 network, whatever may be, my next address is but what? 20.0.20. So we will discuss about R2 router right now. Okay, what is the routes for we need to write for R2 router? Okay, for R2 router, okay, 20 and 30 are available there in the routing table. So which is okay? What is the other network available there in the network here? 10.0.0.0 we have to write a route, and also 20.0.0, so 30, 40.0.0.0 we have to write route because 30 and 20 is already available there in the routing table. We have to write the route for 10 network and 40 network. Okay, so now we'll discuss about this one. Okay, what is the command we have to apply here? Okay, first thing, R2 router, right? R2 router. So config here, IP route here. So here, what is the network we need to write route here? 10 network. We have to write route for 10 network, right? From R2 router, okay, I want to reach my 10 network here. Where is 10 network available? Here is available this side. Okay, from R2 router, okay, this is the way to reach my 10 network. Okay, from R2 router, if you want to reach my 10 network, I have to go here this way to reach my 10 network. So if you want to reach my 10 network here, okay, I have to go here this way only. So now from R2 router, what is my next address to reach my 10 network? Next jump. Okay, I have to go this way, right? Next jump. What is the IP address here? 20.0.0.10 is your next address. So I can write here IP route. Okay, 10.0.0.0. Okay, 255.0.0.0. So what is the next address here? I can say 20.0.0.10 here. That is your next address. 20.0.0.10. Okay. So if you want to reach me 10 network, I have to go in this way, right? 10 network address only we have to give 10.0.0.0, 255.0.0.0, 20.0.0.10 here. Similarly, I want to write the route for 40 network. Where is 40 network available? 40 network available this side, right? Okay, I have to go here this way to reach my 40 network, right? So I have to jump like this. This way only I can jump. Okay, so I can write here IP route. Okay, 40.0.0.0. Okay, then 255.0.0.0. So what is the next address I need to find from R2 router, right? To reach my 40 network, what is the next address here? Next jump. What is the IP address available here? 30.0.20. That is the next address here. 30.0.0.20 here. That is the next address. This is syntax for R2 router. We have to write the route for 10 network as well as 40 network. Right now, we'll discuss about R3 router. What is syntax for R3 router here? Okay, R3 routers knows about 10 and 40. Okay, so we need to write the route for 10 network and 20 network, right? 10 network as well as 20 network. We need to write the routes. 20. We need to write the route for 10 and 20 here. So what is syntax here for R3? Okay, R3 router. R3. Go to the configuration mode. We have to write the route. What is the command? IP route. Destination network. What is the destination network here? 10 as well as 20 is a destination network. So first we will write the route for 10 network here. So 10 is where 10 is available here, 10 is available this side, right? So from R3 router, I need to reach my 10 network. R3 router from I3 reach my 10 network here. From R3 router, what is my next subaddress? I am not saying next subaddress. My next subaddress. My next jump. My next jump. What is the IP address available here in the my next jump here? Next hop. IP address of the next router. What is available here? 30.0.10 here. Okay, so I can write IP route here. Okay, 10.0.0.0, 255.0.0.0, okay, 30.0.0.10 here. Finish. Similarly, I need to reach my 20 network also, right? I have to write the route for 20 also, right? 20, where 20 is available, here 20 is available, right? Through this way only, I can reach my 20 network. So, from R to router, next jump. What is the IP address available here? 30.0.0.10. So, I can write, okay, IP route. So, 30.0.0.0, 255.0.0.0, okay, right? 20 dot, it should be 20, right? 20.0.0.0, 255.0.0.0. My next address, my next jump should be 30.0.0.10 here. Okay, so this is the command router, this R3 router, R3, the configuration mode. So this is the command we need to configure for R3. Okay, so R1 router, R2 router, and R3 router. If you configure, so R1 router will have 10, 20, 30, 40. R2 router also will have 10, 20, 30, 40. R3 router also will have 10, 20, 30, 40. So because of this network, I can reach from 10 network to 40 network. Because all the routes are available there, right? I can reach from 10 network to 40 network. So we'll do this in the lab here. So first thing, I need to configure the IP address for the router, right? First, I can create a topology here. So first router, second router, and third router. Okay, then I can add a switch here, 2950 model switch here, two switch, more switch here, PC, I can connect a PC. Okay, then open a router here, power of the machine, add NM4AS card and power on. Open the router, power off, NM4AS and power on. Open the router, power off, NM4AS and power on. So now connect the cable. From router here, you can connect the cable. So then configuring the, you are going to configure the router, right? So this is the IP address you are going to configure 10.0.0.10 here. Here this same 20.0.0.10, 20.0.0.20, 30.0.10, 30.0.0.20, 40.0.0.10. This is an IP address 255.0.0.0. Okay, so this is IP address we are going to configure the router. Open the router, go to CLMO. First, you can apply no command. We are going to configure the IP address, right? So we can say first thing, enable command, config TE. Okay, host name, you can change the host name here. Host name as R1. R1 change the host name. Then interface INT F8070 IP address. So 10.0.0.10 here. 255.0.0.0. No shutdown command. No shutdown. Exit. Interface serial 170. IP address. Okay, at 20.0.0.10 here. 255.0.0.0. No shutdown command. Clock rate. Exit. Finished. Configuration over. Second router, we are going to configure 20.0.20 and 30.0.10. So first thing, you can apply no command here. Enable config T, global configuration, host name. You can change the host name here. So host name, you can say R2, second router, right? R2 router. Interface serial 170. IP address. IP address 20.0.0.20 255.0.0.0. Okay, clock rate, you can apply clock rate 64,000 here. Okay, no shutdown command. Exit. Next interface serial 1/1 IP address. So 30.0.0.10 here, 255.0.0.0, no shutdown command, clock rate here. Finished. Exit. Next router, third router, CLI mode. Enable config T, hostname R3, interface serial 1/0, IP address 30.0.0.20, 255.0.0.0, no shutdown command, clock rate. Exit. Interface FA050, IP address 40.0.0.10, 255.0.0.0, no shutdown command. So we configure the IP address for the router. All the router we configure the IP address. Now I want to check the routing table here from R1 router. R1 router, it should have 10.0.0.0 and 20.0.0.0. R2 router should have 20.0.0.0 and 30.0.0.0. R3 router should have 30.0.0.0 and 40.0.0.0. So R1 router 10, 20 will be available there in the routing table. Okay, I have to check it here by giving show IP route command. Show IP route command, I can see R1 has 10 and 20 available there in the R1 router. Second router, R2 router, I'm checking R2 router, show IP route command, 20 and 30 available there in the routing table. R3 router, show IP route command, 30 and 40. Okay, so R1 10 20, R2 20 30, R3 30 40 available. Now I want to apply the static routing protocol. Okay, static routing protocol. Before that, if you want to check the connectivity, yes, you can check the connectivity from R1 router. So ping command 10.0.0.10 I can communicate. Similarly, ping command 20.0.10 I can communicate. But 30 I am not able to communicate because the routes are not available there in the routing table. Okay, 30 is not available there in the routing table, so it won't communicate at all. Similarly, 40 also I am checking, 40 also won't be available there in the routing table, so it won't communicate. You can see here, it won't communicate at all. Okay, now I want to configure the static routing protocol. We know the command, right? So here you can say this is the command. I want to configure in R1 router. Okay, I want to configure in R1 router. So IP route 30.0.0.0, 255.0.0.0, next address 20.0.0.20. Clear? Similarly, IP route 40.0.0.0, 255.0.0.0, 20.0.0.20. Finished. Configuration over for R1 router. So I want to configure for R2 router also. Okay, config T, IP route. Okay, 10.0.0.0. Okay, you can see the command here 10.0.0.0, 255.0.0, 20.0.10. Similarly, 40.0.0.0, 255.0.0.0, 30.0.20. So okay, so IP route here. Okay, 255.0.0.0, 20.0.0.10 here. Next address. IP route 40.0.0.0, 255.0.0.0. My next address sentiment 30.0.0.20. Third router. So third router I need to configure with 10 and 20. The next address 30.0.10 and 30.0.20. So I can configure, go to the configuration mode here. IP route 30.0.0.0, 255.0.0.0, next address. Next address nothing but 30.0.0.10 here. sorry, 10 dot, it should be 10, right? 10 dot 0 dot 0, 250 dot 0, 30 dot 0, 10 is the next router. Similarly, IP route 20 dot 0 dot 0 dot 0, 255 dot 0 dot 0 dot 0, 30 dot 0 dot 0 10 here. Okay, because R1 rotation is 10 and 30 and 40, right? We need to write the route for 10 and 20 only. Okay, completed. So configuration over. All the configuration completed. Now I want to check my routing table here. From R1 router, I can check the routing table here. Show IP route command. Okay, if I give show IP route command, I can see all the networks should be there in the routing table. You can see 10, 20, 30, 40 available there. Similarly, for R2 router also, all the networks should be there. Okay, show IP route command 10, 20, 30, 40. Okay, R3 router, you can see here 10, 20, 30, 40. So now I try to ping from, okay, I try to ping from R1 router, okay, to 30 network and 40 network. You can say 10 and 20 already reach, right? Okay, 20 also I can reach here, already we know. Okay, 30, we need to try 30 for 30 network here, 30. Now I can able to reach my 30 network here. Similarly, 40 also I can able to reach. You can see here, 40. Okay, so I can reach from my R1 router to, okay, R1 router to my 30 network as well as 40 network. Now I want to check the connectivity from my PC to one PC to other PC. You can assign the IP address for the PC first of all. Go here, you can assign the IP 10.0.0.1 here, 10.0.0.10. I configure the IP address for the PC here. Similarly, second PC, desktop here, IP config 40.0.0.1 here, 40.0.0.10 here. Completed. So I can check the connectivity from first PC to last PC here. Open a PC, go to command prompt, ping 40.0.0.1 here. Okay, if I give enter, you can check the connectivity, whether I can able to communicate or not. Yes, I can communicate, right? Okay, so from first PC to second PC, I can able to communicate. Similarly, we can apply the trace command. What trace command will do? Trace command, if I apply trace command, it will trace the path from source to destination. So for example, if I apply trace command here, if you apply trace command from this PC to this network 10.0.0.10, then next hop 20.0.20, then next hop 30.0.20, finally reaches the other PC. Okay, you can see the next hop here by applying trace command, trace RT 40.0.0.1 here. It goes hop by hop. You can see 10.0.10, 20.0.20, 30.0.20 and 40.0.0.1 here. Okay, you can see here 10.0.10, 20.0.20, 30.0.20, 40.0.1. Finally reach a 40.0.1. So this is the configuration for static routing protocol. Okay, we know how to configure the static routing protocol here. First thing what we have done, this is the topology diagram. Okay, so we understood that static routing protocol is nothing but administrator manually configure the network to reach the remote network. So routing table has to be created, maintained, updated by the network administrator. So the static routing protocol, we need to configure in all the router to get the full connectivity. IP route, destination network, subnet mask and next hop address. This is syntax for static routing protocol. Here there is a command. We configure this one, IP route, okay, 30.0.0.0 and so 40.0.0.0 for R1. Similarly, R2, 10.0.0 and 40.0.0 we configure. For R3, 10 and 2/20 we configure in R3 router. After configure, we check the routing table here, show IP route command. All the networks are available in R1, R2 and R3. Similarly, for R2 router, R3 router also we can see the network here. After that, we try to ping from R1 router. I can able to reach. Success here. Okay, 30 network as well as 40 network also. Here, we understood about administrative distance as well as metric here. Okay, when you check here in my routing table, if I give show IP route command, okay, if I give show IP route command, I can see 1/0 is available. 1/0. Here, 1 represents administrative distance, 0 represents the metric value. Okay, when here we can see C. C means what? Directly connected. C represents directly connected here. Directly connected. S represents static routing protocol. It's called a static. So 10.0.0.0 slash 8. 10.0 slash 8 here. 8, this 8 that represents what? Okay, C submask first it's represented in CADR method. Okay, classless inter-domain routing because 8 ones are available in 255. That's what represents slash 8 here. So here 30 network and 40 network has been reached via 20.020. So next up address. So in a routing table, what are the information available here? Network address, destination network address available. Then we have subnet mask available here. What kind of protocol, whether static routing protocol or default routing protocol, what kind of protocol is available? Apart from that, we can see the next hop address. Okay, then metric value as well as administrative value, administrative distance value available. So in the routing table, we have multiple information available. Okay, network address, destination network address available, subnet mask available, next hop address available here. Apart from that, administrative distance, metric and protocols, routing protocol available here. So the next thing, what is administrative distance here? Administrative distance, AD value. Administrative distance nothing but, okay, it determines the which protocol, which routing protocol need to trust the most. That means trustworthiness of the route is called as AD value here. Trustworthy. You can say trustworthy. So that means which is your best protocol. Which protocol we need to trust. That is called as what? AD here. Administrative distance value. Okay. So if I have multiple protocol, might be I can say static routing protocol, default routing protocol, EAGRP, OSPF, okay, RIP protocol, IGRP, multiple protocol available. So we have different administrative distance for each protocol. For static routing protocol, we have AD value of 1 here. Default routing protocol, AD value of 1. Okay. EAGRP 90, IGRP 100, OSPF 110, RIP protocol 120. But which is the best protocol, sir? The protocol, okay, which is the best protocol here? Which protocol we need to trust the most? The protocol which is having the lowest administrative distance. Okay, that only wins here. Okay, so lowest administrative distance wins here. So if I have multiple protocol available here, okay, static 1, default 1, EAGRP 90, IGRP 100, OSP 110, RIP 120, lowest wins. Always lowest wins here. So if I configure static routing protocol, we know, right? If in a network, if we configure with static routing protocol, OSP protocol, and RIP protocol, if I give show IP route command, it display only the static routing protocol because it has a AD value of 1 here. Okay. In a network, okay, suppose for example, in the network, I configure with static routing protocol. Okay, I configure static routing protocol, then I configure with OSPF protocol, configure with EAGRP protocol, multiple protocol configure. But if you give show IP protocol, show IP route command, it display only static routing protocol only. Okay, it won't be okay. The OSPF and EAGRP, it does not display. Why? Because whichever having the lowest AD value, okay, that only wins here. So even though if I give show IP route command, here multiple protocol configure, but it show only static route protocol output only. So lowest wins here. Okay, only static routes available there in the routing table. Similarly, if I configure, okay, if I configure EAGRP, IGRP, OSPF and RIP, I configure EAGRP, IGRP, OSPF, RIP. EAGRP is 90, IGRP 100, OSPF 110, RIP 120. But who will win here? Okay, EAGRP wins because EAGRP having a lowest AD value. Whoever having the lowest AD value, it will win here. Okay, so administrative distance of static routing protocol, we know, right? It's a 1 here, 1 or 0. When it will be 1 here, if you configure as a next hop address, its value will be 1. If you configure via exit interface, the value will be 0. Okay. For directly connected network, AD value is equal to what? For direct connected network, it should be equal to 0. AD value is 0. If your router table has a static routing protocol, RIP and EGRP, route to the same network, which router will be used to prefer here? Which router is preferred here? Static routing mode prefer here because the AD value is 1. Okay, AD value is 1. Next thing we are going to discuss about metric. So what is metric here? Metric is nothing but to determine the best route, okay, determine best path. If I have multiple path available, which path I have to prefer? Okay, to determine the best path, we are going for our metric value. To determine the best protocol, routing protocol, we have to go for AD value. Okay, so it allows the router to choose the best path. Okay, so here, for example, okay, consider this a network here, or one router here, another router here, another router, another two routers are available here. Okay, I can go over here directly. I can go over here this way directly, or I can go over here this way also to reach my destination network, or I can go over this way. But if I go over here this way here, okay, this way here, how many routers are available? Two routers are available. But RIP protocol, it uses something called hop count. We'll discuss about RIP later. Hop count. Hop means to jump. If it cross only one router, okay, hop count is equal to 1 here. If suppose this router here, if I cross only one router, hop count is equal to 1. Suppose if I have two routers are available, if I cross two router, hop count is equal to 2. Hop count is equal to 2 here. Okay, one hop count and two hop count. Hop count is 2. For this path, hop count is how many hop counts are available? 1 and 2. 2 hop count. For this path, how many hop counts are available? 1, 2, 3. Hop count 3 hop count available. So this path 1, 2, 3, 4 hop counts are available. So now which is having the lowest hop count here? 2 is having the lowest hop count. Because of this, RIP protocol choose this the best path here. So best path can be calculated by using a metric. RIP protocol uses hop count. As well as we have EHRP and as well as IGRP protocol which uses composite metric. OSPF protocol uses cost metric. We'll discuss all the things. So now understood how we can calculate the metric here. Okay. So if I have multiple protocol available here, you can see RIP have RIP uses hop count for finding the best path here. EHRP uses composite metric. IGRP uses composite metric. OSPF uses cost here. So you can see the path here. There are two paths available in this network. So both are going to reach the same network only. Okay. So 192.168.111.0/24. Here 192.168.110/24 here. 120/1. 120 is nothing but your AD value. 1 is your metric value. 120 is your AD value. 5 is your metric value. So the path which is having the lowest metric, okay, R1 is having the lowest metric, right? So router will choose this path to reach the destination. It won't choose other path. The traffic will be forwarding via first path because it has the lowest metric value. So router uses the best path. How to find the best path here? It finding the best path based on the metric value. Next thing we have to find out, we have to go with advantage and disadvantage of static routing protocol. What is the advantage? What is the advantage here? So advantage is nothing but it uses less CPU and memory because everything you configure. Okay, all the configuration you are doing in the router. So router does not use much CPU and memory. Okay, for calculating the best paths. Okay, or calculating the routes also. Okay, you are confident as administrator, you are doing all the activities. You are doing all the activity, right? So you are doing all the activities. So the best path can be calculated by using this method. Best path can be calculated. Okay, by using this. Okay, metrically. Here, less CPU and memory utilization, right? That means what? Less CPU and memory. It uses less CPU and memory because you are configuring everything, right? Okay, you are configuring all the things. Like whatever activity you are doing, you are configuring all the things, right? Okay, less CPU and memory utilization. Next thing, more secure. More secure. Why it's more secure? You are configuring. The routes has been configured by you. Okay, so you know which is the best path, which is more secure. And also no bandwidth overhead here. So we can control granular control on how traffic is routed here. Next thing, disadvantage of static routing protocol. What is the disadvantage here? Does not support a large network. If I have 3 routers available, I can easily configure the router, right? If I have more router available, okay, 100 routers are there. Is it possible to configure static routing protocol? No, it's very difficult. If it is a small network, it supports. For large network, static routing protocol does not support at all. It's very difficult to configure. And also, if you want to configure static routing protocol, admin should know the complete topology. Which router is connected to which router? What is the interface it's connected? What is the next hop address? Admin should know. Then only they can able to configure properly. Otherwise, it will make a mistake. Okay, so admin should know complete topology. Next thing, no fault tolerance. What is the meaning of fault tolerance here? If there are two links available, if one link goes down, it won't choose the other link automatically. As administrator, we have to manually configure for other link also. Okay, that's called the fault tolerance here. Automatically, it won't choose the other path to reach the destination. Okay, no fault tolerance. If the one link goes down here, it won't choose the alternate path. Okay, here admin has to manually configure to reach the destination. Next thing, infrastructure changes must be manually adjusted. It won't do automatically. Whatever thing we have to do, it has to be done by the administrator. It complete control over the administrator. Okay, admin has to choose, admin has to configure. That's called static routing protocol. A static routing protocol, administrator manually configure all the routes. Okay, even though if any if path goes down also, he has to configure manually. Okay, so that is a drawback here. Okay, in static routing protocol. Clear? Thank you.